This is our final unit with the topic of systems of equations, systems of inequality. So we know that a system consists of two or more functions. With our examples this year in algebra, it's two or more lines. So we are looking at graphing two linear inequalities. So it has the less than or greater than symbols on the same exact graph and determining what the area of intersection is. So I'm going to first graph y is greater than negative 3x plus 5. I'm starting on the y-axis at 5. And then my movement is down 3, right 1, down 3, right 1. Remember, that is the same as going up 3, left 1. I do want to make sure that I am graphing a negative slope. Then we have two decisions to make. We need to decide, is this a solid or dashed line, and where we shade at. So because there is no equal to sign, we are looking at a dashed line. And then where I shade. So since it's greater than, I'm going to shade on the region above my dashed line. If you have trouble determining which region is above, I like to look at the y-intercept. So my y-intercept is 5. All the numbers that are above it are greater. The numbers that are below it are less than. So since I want to graph the greater than sign, I'm going to graph to the numbers that are greater than 5. So I'm going to shade in the entire region above my dash line. Onto my second linear inequality. Y is less than or equal to x minus 2. So my starting point is negative 2. I have a slope of that imaginary 1, so up 1 over 1, up 1 over 1. And then it's decision time. Solid or dashed line. Because it is equal to, we are going to have a solid line. Now the inequality determines if I shade everywhere above the blue line or everywhere below the blue line. So if we're having trouble, we're going to go to my y-intercept. The numbers going up are above, the numbers going down are below. Because it's less than, I'm going to shade below the line, and I'm going to make sure that I shade everywhere below the blue line. So my solution set is where the yellow and the blue intersect. And as I'm sure you know from art class, when yellow and blue intersect, they make green. So my solution region is the green area. In class, we were talking about what are possible solutions. So we look for coordinates that fall in that solution region. So 6, 0, 9, 3, 8, negative 5 are all possible solutions. Anything that lies on the solid line is possible solutions. If it is on the dashed line, it is not a solution. So it just needs to be on this green region or within the solid line in order to be considered a solution. And there are infinitely many solutions for this inequality. One more example just to make sure we got it. So we have y is less than 4. So since I'm looking at y, I'm going to go to the y-intercept at 4. I have no slope. There is no x at all. So my slope is 0. We represent a slope of 0 with a horizontal line. Is this a solid or a dashed line? This is a dashed line because it is not equal to. So I have a horizontal line across y is equal to 4. Shading wise, it is less than 4, so I'm going to go underneath the line. My second line is y is less than or equal to 5/3 x minus 1. My starting point is at -1, up 5 units over 3 is the same as going down 5 units, back 3. It still creates a positive slope. So now I need to decide solid or dashed. Because of the equal to symbol, this is going to be a solid line. And then now I have to shade. So I have my numbers above and my numbers below. Because it is less than, I'm going to shade everywhere underneath my blue line. And the intersection of the lines is the green region. Therefore, my solution area or solution set is that green area. So possible solutions will lie inside of this area or on the solid line.